In this problem, we're asked to find the voltage V0, and if we note our circuit contains a set of coupled inductors, so we're going to be utilizing the problem-solving strategy entitled magnetically coupled inductors. And if we look at that strategy, it says first assign mesh currents. So let's assign mesh currents. I'm going to assign I1 to this mesh, I2 to this mesh. Okay. Now we're going to write mesh equations by applying KVL. And the way we'll handle the dots is if a current enters a dot, it produces a voltage at the other coil that's plus at the dot, and vice versa. So let's start up here on the upper left, and let's begin to apply KVL. So for instance, we'll have 2I1, that's a drop across the resistor. Now for our inductor, we have two voltage terms, one due to current I1, and it's polarized like that, and it's J2I1. Now the current enters the undotted terminal, so it's going to produce a voltage with that polarity over on this coil, and our value is J1.5, so we have J1.5 I2. And notice it's going to be, this has this polarity, this one has the opposite polarity, so we have minus J1.5 I2. Then as we come on around, we have minus J3I1, and that's equal to 24. And if we simplify our equation, then we have 2 minus J1I1 minus J1.5 I2 equal 24 at an angle of 0. Now let's go up to our second mesh. We'll have minus J2 I2 plus J4 I2 plus 2 I2 plus 10 at an angle of 30. Okay, now as we come around to our coupled inductor, we'll have one term due to current I2. That'll be polarized like this, and it'll be J2 I2. And we would have that term even if the inductor were not coupled to another inductor. Now, over on this coil, current enters a plus. It's going to produce a voltage with that polarity over in the second coil, and that voltage is going to be J1.5 I1. Notice that that has the opposite polarity to this term, so we're going to have a minus J1.5 I1, and that's equal to 0. Now, if we simplify here, we're going to have minus J1.5 I1 plus 6 plus J4 I2 is equal to minus 10 at an angle of 30, which is 10 at an angle of minus 150. Now, if we solve using MATLAB, here's what we get. We get I1, and we really only needed I2, so we solve for I2. We get minus 1 plus J2 amps. Okay, so we only needed to solve for I2, so we got that from MATLAB. Now, if we look over here at our circuit, V0 is a voltage across these two elements, so V0 is 2I2 plus 10 at an angle of 30, and that's 11.2 at an angle of 53.5 degrees volts.